In this lesson, we are going to study the structure of DAX formulas and references. We will learn what each piece of information does and how to properly call each of them. Understanding well this structure will make our lives much easier when writing DAX codes. Okay, let's learn how to reference data in Power BI. When you're working in Power BI, we are working with tables. And in Power BI, and the same goes with Power Query, each table has to have a unique name. You cannot have more than one table with the same name. Of course, the table name is its unique identifier. You can have more than one table with very similar names, but not quite the same. For example, you could have one table that is called sales and another one that's called sales dot or sales underscore or sales plus. So you can have small differences, but you can never have more than one table with the same name. So in this example, we are using a table that is called sales. So our example is the sales table. And in the sales table, we have four columns, and one of them shows the purchase date or the sales date actually. The other one is the revenue for each sale, the expenses, and the amount of returned products for each sale. And we are going to use this table as an example for this entire lesson. So this table, of course, it has a table name, which is sales. And as you can see, each column has a name. So column names are also references to data in our Power BI table and also Power Query tables. Actually, this pattern goes for all programming languages. I just want to remind you that tables not necessarily have to have multiple columns and multiple rows. So we can have tables with multiple rows and multiple columns at the same time, but we also can have tables with a single column and multiple rows. It's also a table. And we can also have a table like this with more than one columns and just one row. And we even can have tables like this with only one column and one row, and it can still be considered a table. It is important to notice, though, that whenever you are working with tables, your column, even though it's a single column with a single row, you have to have a column header. And this column header or column name is a characteristic of a table. So if you have a column name, you know that you're working with a table, even though it could be a table with only one row and one column. Whenever we want to reference the entire table in Power BI, we are going to use, of course, the table's unique name. It is important to notice that if we only use the table's name, we are going to be referring to the entire table, all of the rows and all of the columns in the table. And please notice that when we refer to the table using the table name, we are only referring to the content of the table. If, for example, I'm using the content of the sales table for performing calculations or evaluations or of data treatment, I'm talking about the content of the tables. We are not using the column headers in our calculations. Of course, we could take the column names and bring them into the table and have these column names become actual data inside the table. And we study that in our Power Query Foundations course. We learn how to use column headers and transpose them from headers to rows. And this is an example of how we could have the column names become data inside our table. But in this example, as a rule of thumb, when we are referring to an entire table, we are using the data that is inside the table, not the column headers. The column headers, as a rule of thumb, they are not part of our calculations, okay? And how about when we want to refer only to a single column instead of the entire table? It's very easy. Whenever we want to refer to a single column, we are going to keep the table's name and add the column's name within brackets. Okay, so we will have this is the pattern. We are going to have the table name and then the column name will come right after, but always within brackets. And this pattern is very effective because it prevents you from confusing different columns that eventually could have the same name but in different tables. So you can never have more than one table with the same name, but you can have different columns with the same name as long as these columns are in different tables. Of course, you cannot have in a single table more than one column with the same name, but you can have columns with the same name in different tables. So what differentiates one column from another is the table name in the beginning. So you always will have the reference of the table and then the column in that table. So that's a very efficient way to reference just the data you need for your formulas. Likewise, if I want to reference the revenue, the values in the revenue column, I'm going to use the table name, which is sales, and then between brackets, I'm gonna reference the column name. And again, I'm referencing the sales table and the revenue column, but I'm referencing actually the values in this column. Okay, and again, with the returns column, I'm gonna have sales table and the returns column between brackets. And now let's study this DAX formula. This DAX formula, it's a standard structure for DAX formulas. We will understand each piece of information, what each of them is called, and what they do. It is important because this pattern will be followed for any DAX formula. And understanding all this will make our lives easier and will make our communication easier, since from now on, I'm going to use these very same terms to describe each part that we're going to discuss and learn in our DAX lessons from now on. Okay, so what I have here, I have a formula to calculate the sum, and it's very easy to understand what we're doing here. We are summing up these values: 10,000, 15,000, 12,000, 9,000, and again 10,000, which are the same values as you see here in the revenue column from the sales table. So what I'm doing here, I'm saying, hey, Power BI, please run a calculation for me. Call this calculation total revenue. Call it total revenue. And the total revenue is a calculation that will be performed like this. I want you to sum all of these numbers that are coming from this column right here, the revenue column. So it's this one. This formula is very easy to understand, very intuitive. And this same structure goes for all the formulas, and some of them may not be so intuitive, but the underlying structure will be the same for any DAX formula. And okay, you can see that I have many numbers inside this piece of information. The blue piece is what we call a function, and inside the function, I have the numbers that I want to sum up. And these numbers, which are the pieces of information that come inside the function, this green part, these are called the arguments of the function. And out of the arguments, I have the function itself. So let's differentiate a function from the arguments of a function. A function is a command. It's an instruction that you give Power BI and when you want it to perform some kind of task for you. And what is the task I'm performing here? I'm saying, hey, what is the command I'm giving Power BI here? I'm saying, hey, Power BI, go ahead and run this function. The function that I want you to run, or the task I want you to perform, is this. I want you to sum up, and functions always start and end in parentheses. Okay, so you always will have a function starting and ending with parentheses, and within these parentheses, you will have the pieces of information that are important for this function to work. And these pieces are what we call the argument of the function. In this case, the sum function has 1, 2, 3, 4, 5 arguments, and we can make that more efficient, because what if we had, instead of 5 numbers, what if we had 5 million numbers? So of course, I wouldn't type in 5 million numbers for Power BI to sum up. And we're going to talk about it in a bit. But now we already know what a function is. A function is a piece of command or an instruction we give Power BI to perform for us. And the arguments are the data or the pieces of information that Power BI needs to perform that function. Of course, I cannot sum any numbers if I don't have the numbers to sum. So that's why these arguments are the pieces of information that the sum function needs to work properly. And then we come to the calculation name. So whatever is before the equal sign is the calculation's name, and whatever is after the equal sign is actually our formula. And we haven't seen the word formula here, but we will soon. So the calculation name will be used in measure names or calculated columns name. The calculation name, it depends on what you are creating. And in our Power BI course, you have a lesson explaining in detail what are calculated columns and what are measures. So they are very crucial concepts in Power BI, but the DAX formulas will work somewhat the same both for measures and calculated columns. Of course, there are some differences. The way they will show up whenever the calculations performed are different, because of course, when you have a measure, you will use a measure in different visuals. And these visuals are usually different from tables. And in our Power BI course, we have a lesson explaining in detail the differences between measures and calculated columns. What I want you to understand here is that this calculation name, depending on whether you're creating a measure or a calculated column, if you're creating a measure, so this name will become your measures name. And if you're creating a calculated column, this name will become your column, your new columns, your new calculated columns name. So when I use the general term calculation name, I'm saying that it could be your measures name or your calculated column name, depending on whether you're using a DAX formula to create either one. Okay, so these are the basic parts of a DAX formula, and what we call formula is actually the whole thing. We'll see that in a second. And now I'm showing you a smarter way to do the same calculation we were doing before. Look, we were calculating all of the values in the revenue column one by one. And like I said, what if we had a column with 5 million values, 5 million numbers? Of course, we are not typing in this formula all of these numbers. So a quicker and smarter way to do it is just, instead of typing in each of these numbers, we can just make a reference, as we just learned, we can make a reference to the entire revenue column. So we are summing up, our function is a function to sum all of the values from the sales table and the revenue column. When I refer to an entire column, I'm referring to all the values in that column. It doesn't matter how many rows or how many numbers I have in that column. For example, if I add new rows and new numbers to this column, so my calculation will reach all of these rows because I'm summing up everything from this column, this revenue column, regardless of the number of rows in the column. Okay, so it's much quicker and you don't have to type in the numbers. It makes your life much easier. And again, in this case, I will only have one single argument in this function, and this single argument will be the reference to the column whose numbers you will be summing up. And now finally, we come to what we call a formula. And let's consider a formula as your entire code. And you will have on this side of the equal sign, you will have your measure or calculated columns name. And on the right side, you will have actually your formula. And in your formula, you can have multiple functions or just one function or no functions at all. So the formula will basically be your code. And you can have, like I said, many functions working together, or you can even have no functions at all. And I'm going to give you an example of that. Okay, let's see yet another example. And now we have a more complex function. And again, you can see that the blue part, it's a new function. This function is called SUMX. It's slightly different from the sum function we used before. And again, you can see that this blue part, starting with the parenthesis and ending up in a parenthesis, closing parenthesis, this is a function, the SUMX function. And the parts that we have inside the functions are my arguments. And the arguments of a function are always separated by commas. And you can only see one single comma in this formula, which suggests that we only have two arguments, and that's just what we have. We have the first argument, which is sales, which is actually the table's name, and all of this will be our second argument, So profit is the measure's name. In this case, we're creating a measure, and profit will be the measure's name, and the function will be the SUMX function, and the arguments will be the table from which we are retrieving the data to sum, and then we will have the values in the sales table and revenue column, plus the values in the expenses columns, plus the values in the returns column. So what I'm doing here, I'm calculating the profit. And the profit, what is the profit going to look like? It's going to actually be the revenue minus the expenses minus the returned merchandise, the returned sales. But actually, you can see that expenses are already negative, and so are returns. So as they are already negative, I cannot subtract them from the revenue because they're already negative, right? So I have to sum them up. So my final result will be my profit. And now you can see that this function actually has two parts. It has two arguments. The first argument is the table, And the second argument is the calculation that I want to run in each row. Of course, we will have a specific lesson explaining the x functions, the sum x functions, the average x function, the count x functions. So they work different from the sum function, because the sum x function is actually an iterating function, and the sum function is an aggregation function. And if you still don't know what aggregation is or what iteration is, please refer back to our Power Query Foundations course, and we have lessons explaining what is grouping, what is aggregation, and what is iteration. And you absolutely need to know these concepts before you can develop your skills in the DAX language. So this one, SUMX, it's an iterating function. It means you will run calculations on each row. And in this case, it actually starts iterating. It starts running this calculation row by row. So row by row, it's going to add up revenue and then expenses and returns. So the same for the second row, the same for the third row. So it means for each row, you will be calculating the profit for each of the rows. And at the end, you are going to sum all of these row by row profits, and then you will have the total profit for the table. So it just works different from the regular sum function. Don't worry about it. I don't want you to understand I don't want you to learn how each of the functions work at this point. I just wanted to understand the structure and how the codes are written. And now you can see that this part is the first argument and this is the second argument. It doesn't mean because you have three different references, you're referencing three different columns in the same table, it doesn't mean you have three different arguments and plus the first argument, which would make four arguments. You don't have four arguments here. You just have two, and that's why you have only one comma separating these arguments. And all of this part is just one single argument. But as this argument is composed of many parts, you would call this argument, you would call it an expression. Okay, so an expression is basically a more complex argument that represents a calculation in itself. And now you have an expression, which is actually an argument, and you have the blue part is the function, and this orange part is the calculation's name, which is a measure's name or calculated column's name, and the whole thing would be considered our formula. And now let's jump into quick examples in Power BI. Okay, I have already loaded the sales table in Power BI. In our Power Query Foundations course, we learn exactly how to import every kind of data into Power BI. So if you still don't know how to do it, please watch our course, and we have lessons on each type of data import using SQL Server and using Excel files and using text files and CSV files. So we have all that in our Power Query Foundations course. Please refer back if you don't know what we are doing here. So I didn't show you how to load this data because we have it all explained in our other course, in our Power BI Foundations course. And as soon as we release the data pack for this course, you will have access to this data set, okay? And what we're going to do, please note that we have the same table, the same sales table we were using in our example, in our PowerPoint slides, except we don't have the returns column. We have the date column, the expenses, and the revenue column. It's good enough for our example here. And I'm going to show this table in the table view. And let me just format the dates. Okay, column tools. Let me format as a short date, like this. Okay, and again, let's create a calculated column. In this calculated column, I want to calculate the profit. And the profit in this case is going to be simpler because I only have the revenue and the expenses. In this case, the expenses are positive. So to calculate the profit, what I have to do, I have to calculate revenue minus expenses. And I have to do it in an iterating way because I have to calculate the profit for each of the rows. So in this case, I'm going to Table Tools and calculate a new column. And this calculation is going to be performed with a DAX formula. And like I said, before the equal sign, there's going to be the new column's name. Remember, I said our calculation name will become our column name if we're creating a calculated column, or a measure name if we are calculating a measure. In this case, I'm creating a calculated column. So the calculation name will be the column's name. And the name I want here is profit. And the calculation will be very simple in this case. Remember, I told you that not necessarily we need to have a function, a DAX function in our formula. We can write a formula that is just each row in this column minus each row in this column. I don't have a specific function to do that. I'm just using simple mathematical operators, and I will refer to my table, which is the sales table. Actually, I only have one single table in this data model. I could have multiple tables, but in this case, I only have one. And like I said, we start referring to the table's name, and then between brackets, I'm going to refer to the column name. In this case, Power BI is smart enough to suggest what options I could pick from. Once I have typed the table name sales, so it's going to open up an intelligence dialog box that helps me choose between the available columns in that same table. In this case, I want the expenses column, and what I'm going to do, I'm just going to use a mathematical operator. It's going to be minus, and now I am using sales and expenses. In this case, like I said, expenses is positive, so the profit will be revenue. Well, actually, it's revenue here. Sorry, it's revenue. Okay, sales revenue minus sales expenses, because expenses are positive, so I have to do this minus this. And you can see that I don't have a function, a DAX function here. I can consider it a DAX formula, but actually there are no DAX functions here. I'm just referring to regular columns with a simple mathematical operator, with this the minus sign. And I will hit enter, and now the profit has been calculated row by row. Okay, row by row. And now I can create another one. I will create a new table. Well, actually, I don't want to create a new table. I'll create a new column. And this column will be the total profit. And in this case, I want to sum up everything in the profit column. And yes, we can use calculated columns to create other new calculated columns. We can create measures to create new measures. And in this case, I'm going to sum everything vertically because I'm doing an aggregation here. I'm running an aggregation, and now I'm summing up everything from the sales table and the profit column. Since I calculated the profit column, now profit column becomes available to me as one of the physical, I can call it a physical column in the sales table. And you will see that when I press enter, I will have the same value in each row. Okay, I have the same value in each row. Why? Because I'm asking Power BI to calculate the sum of everything in the profit column. Of course, the sum is a single number. It's a scalar number, scalar value. So it's just one number that I cannot split up between among all of the rows, because if I did it, I would have the same values, of course, as the previous one, which is the profit column. So actually, it doesn't make a lot of sense to calculate aggregations in a calculated column, because the result will be this. You will have an aggregated value repeated for each row. Okay, in this case, the sum function, it just makes more sense in a measure. And let's create a measure, and I will create a new measure. And in this measure, I'm going to call it total profit. And this is going to be, again, the sum of everything in the sales table from the profit column. And you'll see that a problem will emerge. I'm going to press enter, and it doesn't let me create a measure with the same name as a calculated column that has been created before. I created a calculated column called total profit, so it won't let me have a different object. Even though it's not a calculated column, it's going to be a measure. But even though it's a different object, it won't let me have two objects with the same number. So I can't call it total profit because I already have a calculated column called total profit. So what I can do here, I can, for example, insert an underscore in the middle. It's not the same. It's very similar, but it's not the same name anymore. And now the measure is calculated. But as you know from previous lessons in the Power BI course, a measure does not appear by itself. You need a visual so you can show your calculation. And I will drag this measure over and drop it into the visual. And now I have 5.9 million. Let me change the way it is shown. Okay, and now you can see that the aggregated value is the same, 5.89, the same as here, 5.89. Okay, and these are just examples of DAX functions. In this case, I'm using the sum function. For the total profit, I'm using the sum function, but for the profit column, I'm not using any function at all. So this formula has no functions. This formula has one function. And as we move forward, you will see that we can have formulas with a lot of integrated functions working together. So I hope you like this video. I tried to communicate all the important points about DAX structure and understanding what every part of a DAX function, of a DAX formula does, will help us understand what we're going to do in the future. And calling everything by its proper name will help us too. So please don't forget to like and share this content, subscribe to our channel, and your support is very important to us so we can reach more people. So please don't forget to like. Your like and your comments is very important so we can grow our channel and share this content and share knowledge with more people. See you in the next lesson.